Hello, yes, and welcome to our final notes section for the year, 5.7, Graphing Inequalities and Systems of Inequalities. I'm happy to say this section, for the most part, is entirely review from Algebra 1 and Algebra 2. Let's get rid of this already. Now that that's gone, let's dive into the content. So, when we're graphing inequalities, we want to be sure to perform the following steps. First, graph the points for the inequality as if it was an equation. Words are hard. Be sure to show at least 3 to 5 points on the line. Be sure that you're accurate, really. Determine if the inequality should have a solid line or a dashed line. And to do that, remember, we use the symbol. A solid line will be less than or equal to or greater than or equal to. A dashed line will be strictly greater than or strictly less than. And to determine which direction we need to shade. Remember, shading is the key when we're graphing inequality. The shaded region is our solution set. And to do that, I always recommend just plugging in a test point to the inequality. A good test point is the point 0, 0. And I'll show you what that looks like here as we get into some examples. So let's look at letter A here. Graph each inequality and shade the appropriate region, plot a sufficient number of points. Easy. X is greater than 2. Well, the first thing to do is think of this as an equation. Think of this as x equals 2. That's a vertical line. So we're going to plot some points there. Right? Vertical line at 2. There we go. Next, is this a solid line or a dashed line? Well, since this is strictly greater than, right, that we have that greater than symbol there, so this is going to be a dashed line. If it was greater than or equal to, we'd have a solid line, but we don't, so it's dashed. Boom, there we go. Beautiful artwork, Mr. Carter. Well done. Lastly, we need to shade. Okay, so when I said plug in a test point 0, 0, that means whenever there's an x or a y, put in 0. If we get a true statement, we shade the side that has 0, 0. If we get a false statement, we shade the side that doesn't have 0, 0. So for x is greater than 2, that would be 0 is greater than 2. Is that true or false? Well, that's clearly false. 0 is less than true. So I will shade away from 0, 0. So if it was true, I'd shade this side of the line here, but since it's false, I would shade this side, the right side of this vertical line. Fantastic. All right, y is less than or equal to 3. So first thing, think of this as an equation. How would I graph? Whoa, hello. Maybe not. Let me try to, no, what is occurring here? Let's try to write again. I can't write anymore. There we go. Okay. So y is less than or equal to 3. Start as an equation, y equals 3. So that would be a horizontal line at 3. Let's plot some points at y equals 3. Beautiful. Plotting those points, y equals 3. Solid or dashed line? Well, since this is less than or equal to, that equal to tells me it's a solid line. Right at y equals 3. I can go ahead and draw my arrows to show that this continues onward. Excellent. And then let's see here. Plug in 0, 0 for a test point. So 0 is less than or equal to 3. Is that true or false? Well, that's true. 0 is indeed less than or equal to 3. It's less than 3. So that means I will shade the side that has 0, 0. So that means I'm shading below this line here. Beautiful. Excellent. And that's what we're looking to do here. All right, so let's try a couple more. Let's look at letter C. Y is greater than or equal to 2x minus 1. Well, greater than or equal to 2x minus 1. So let's pretend this is y equals 2x minus 1. I have a slope of 2, a y-intercept of negative 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Down 2, left 1, down 2, left 1, down 2, left 1. Beautiful. Solid or dashed line? Well, since this is greater than or equal to, I would have a solid line. And now my test point, plug in 0, 0. So I would say 0 is greater than, 2 times 0 is 0, minus 1. Is 0 greater than or equal to negative 1? Yes, it is. 0 is greater than or equal to negative 1, so I would shade the side that has 0, 0, which would be this side up here. So go ahead and shade above that line. Beautiful. Alright, why don't you go ahead and try letter D on your own. Go ahead and pause the video, give letter D a shot. Alright, let's see how we did. So looking at letter D, y-intercept of -3, a slope of -2/5. So that tells me down to right 5, down to right 5, up to left 5, up to left 5. Alright, solid or dashed line. Well, since this is strictly less than, we'll have a dashed line. So a dashed line connecting these points. Very good. And then as I plug in 0, I would get 0 is less than -2/5 times 0 is just 0 minus 3. So 0 is less than -3. Is that true or false? Well, that is false. 0 is more than -3. So I will shade the side that does not contain 0, 0, which would be this side here. Excellent. There's letter D. Why don't we go ahead and look at, oh, hello, those lines moved with me. Coming in hot. Let's finish these up. All right, so now let's go ahead and look at letter E and F. Looking at some things here in standard form. Now, when I want to graph in standard form, what I would do is I'd try to get this in slope-intercept form. So let's see, we got some space over here on the right, so -7x plus 4y, and we'll just turn it into an equation equals 16. I need to add 4x and then divide by 4, so y would be 7/4 x plus 4. Alright, so 7/4 x plus 4, y-intercept of 4, and then I would go up 7, right 4. I'm not going to be able to fit that in there, so I can go down 7, left 4, and down 7, left 4. That gives me 3 points there. Cool. Alright, if I went up 7, left 4, that'd give me what, 11, 4? So I'd be just off. It'd be something like that. So I can go ahead and mark that. Next thing, solid or dashed line? Dashed line for sure. Beautiful. Dashed line again because it's strictly less than there. And then when I plug in 0, now standard form plugging in 0 is actually really easy because if you plug in for x and y, you're just going to get 0 plus 0. So is 0 plus 0 less than 16? Well, yeah, 0 is less than 16. So that means I will shade the side that has 0, 0. So I will be shading this section here. And all of those values are my solutions. Beautiful. All right, why don't you go ahead and try letter F on your own. Give letter F a shot. Go ahead and pause the video. See how you do. All right, let's see how we're looking here. So when I look at letter F, I will start by adding 5x to both sides. So I'll have -3y, and I'm going to change mine to an equation equals 5x minus 3. And then I divide by -3, divide everything by -3. I'll get y equals -5/3 x plus 1. So plus 1 is my y-intercept, -5/3. So that means I'll go down 5, right 3, down 5, right 3, up 5, left 3. All right, solid or dashed line here. Well, since this is less than or equal to, I will have a solid line. Let's see how I do here. It's not bad. That's not bad at all. Very good. Okay. And now I need to shade. So when I plug in 0, 0, I get 0 is less than or equal to -3. Is that true or false? That is false. 0 is more than -3. So I will shade the side that doesn't have 0, 0, which would be this side here. All right. Hopefully we're feeling pretty good with that. Now let's look at quadratics, okay? We're going to look at some quadratics now. Quadratic inequalities. Now these are the exact same. You graph them like they're an equation. You identify if it's solid line or dashed line, and then you shade. So when you shade here, though, it's either going to be inside the parabola or outside the parabola, which is a pretty cool effect. So let's look at this here. So start graphing as if it's an equation. Y equals 2x squared minus 3. So I'll go down 3. And then remember, quadratics normally go up 1 over 1, but since this is stretched by 2, this is going to go up 2 over 1. And then from there, instead of 3, it'll go 6. So 2, 4, 6 over 1. That'll put me here. There we go. Beautiful. Okay, solid or dashed line. Well, since this is greater than or equal to, we will have a solid line. So go ahead and find that here. Beautiful. Show that those continue. And then I'll plug in 0 for x and y. When I do that, I will get 0 is greater than or equal to 0 minus 3. Is 0 greater than or equal to negative 3? Why, yes, it is. So that means I will shade the section that contains 0, 0, which in this case is inside the parabola. So I will be shading inside my parabola, like so. There's one example. Let's do another together. So looking at h here, y is less than negative x squared plus 9. Okay, so let's pretend it's an equation. Y equals negative x squared plus 9, and let's graph these points. So plus 9 would be my y-intercept. Negative x squared means I'm going down, like sugar. So I'll go down 3 or at 1, and then down 5 from there, down 7 from there. Then I can try to mirror these on the other side. Shout out to the axis of symmetry that allows us to do that so easily. Alright, solid or dashed line? Well, if I strictly less than here, so we're going to have a dashed line. Dashed line parabolas are always a little more difficult to graph, so please excuse my poor handwork here. It's even harder to do on a screen. That's okay. We're making it work in these trying times. There we go. Alright, and lastly, plug in 0, 0. So I get 0 is less than 0 plus 9. Is 0 less than 9? Yes, it is. So I will shade the section that contains 0, 0, which in this case is once again inside the parabola. Excellent. Very cool. Alright, why don't you go ahead and try J and K on your own. Go ahead and give J and K a shot. Oh, those lines are moving with me again. Why are they doing that? Alright, so go ahead and pause the video, give J and K a shot, and then we will be all good to go. Alright, let's see how we did here with J and K. Now you guys probably saw something that occurred here, which will not always occur, but you know, I like to have some fun every now and then. So negative 2x squared plus 4. We go down 2 and then down 6 from there. That take me to negative 4. Beautiful. Again, it's important to know those patterns so that we can stretch them as necessary. This one we needed a solid line for. And if I plug in 0, 0, I get 0 is less than or equal to 4, which is true. So again, we'll shade inside the parabola. It turns out for all of these, we're going to shade inside the parabola. Negative 5's here, 1, 3 from there, 5 from there. That's all we're going to be able to fit there, I believe. 2, 1, beautiful. Dash line for this one, though. Very good. Uh-oh, let's get rid of that. Alright, now that that's gone, let's go ahead and continue these dash lines on our way up. And when we shade inside, we, of course, get this section because 0 is indeed greater than negative 5. Now, we will not always be shading inside the parabola. That's just something that happened here. I don't want you to freak out and think that's the only possible explanation. I just think it gives a cool shape, and to be honest, I like how it looks. Alright, so with that being said, now we're going to move on to graphing systems of inequalities. So pretty much the exact same thing, except instead of shading every section, what I do is I use arrows to identify which direction we would shade for each inequality, and then we only shade the areas that overlap all of the inequalities. That's the only spot that we actually end up shading. So let's try one of these together. Let's look at letter L here. Let's start with x is greater than or equal to 1. So x equals 1 would be a vertical line at 1. Greater than or equal to tells me it's going to be a solid line. And if I plug in 0, 0 here, I would get a true statement. 0 is indeed less than or equal to 1. So I'm going to show arrows to show that's the direction I'm shading for that line. Now x minus y is less than 4. Well, let's start with x minus y equals 4. I would subtract x, so negative y equals negative x plus 4, which means that y would equal x minus 4. So I can graph that. It has a y-intercept of negative 4, a slope of 1, so it's just going up 1 over 1 all the way out of here. And I can see that this is going to be dashed, so I'm just going to go ahead and use these as my dashes as I go through here. Try to make this work. Again, it's a little more difficult on a digital screen, but we're going to figure out a way to make it work. Alright, so when I plug in 0, 0, again to the original inequality, I get 0 is less than 4, which is true. So for this line, we are shading this direction up and to the left. And last one, y is less than or equal to 3. So there's a horizontal line at 3. It's solid since it's less than or equal to. And if I plug in 0 less than or equal to 3, that is also true, so I'll be shading down. So now I need to find the section where all of this overlaps. So my first one, my vertical line, it's to the left, it's below my horizontal line, and it's up and to the left of the dash line here. So it would be this section that I'm looking to shade. There we go. Do we see how that shaded area satisfies all three inequalities? It's to the left of the vertical line, it is below the horizontal line, and it's up and to the left of the dashed line, the linear y equals x minus 4. All right, why don't you all go ahead and give a shot here? Why don't you try letter M on your own? Go ahead and pause the video, try letter M. Let's see how we do. All right, so the order that you do these in does not matter. So if you did it in a different order than me, that's totally fine. I'm going to go ahead and I see a couple here that I want to knock out real quick. X is greater than or equal to 1. Vertical line at 1. Solid vertical line since it's greater than or equal to. Similar to the last problem. And then this one is greater than or equal to, so we'll be going to the right for that one. Negative 5 is less than y is less than or equal to 8. So this is a good compound inequality where we can go ahead and draw 8 as a solid line, a horizontal solid line at 8. And then negative 5, a dashed line down there. And our shaded area is going to be in between these lines. So it's going to be below the top line, above the bottom line. And then we can do x minus 2y is greater than 6. Now for this one, I'll probably get y all by itself here. So we'll say x minus 2y equals 6. So negative 2y would equal negative x plus 6. Divide by 2, so y would equal, I guess divide by negative 2, 1/2 x minus 3. Half x minus 3 would be right here. I can go up 1 over 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 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 2. And this is going to be dashed. Alright, dashed because we have the strictly greater than here. So go ahead and add these dashes to this line. Try my best to make it look good. There we go. Okay, and if I plug in 0, I get 0 minus 0 is greater than 6. Is 0 greater than 6? No, it is not. 0 is less than 6. So that means I will be shading this line away from 0, 0. So from there, we can see I need to be between these horizontal lines, I need to be to the right of the vertical line, and I need to be under the dashed line with the slope of 1/2. So I'm going to be in this section right here. That section satisfies all three. Excellent. All right. Let's try a couple more here. So looking at letter N. Oh boy, so look at this equation. Did it take those dashed lines with it again? Why is it doing that? What in the world? All right, let's put these dashes in here. And then let's think about how lonely we all are, because I miss you guys a lot, and maybe that'll be long enough for them to stay there. Cool. No, they still pop down. I guess they're lonely too. Who knows? All right. So let's look at letter N here. -1 plus x minus y is less than 0, and y is greater than or equal to -x squared plus 6. Okay, so here's a good example. Let's do letter N here. Y is greater than or equal to -x squared plus 6. So 6 would be here. -x squared, so I'd go down 1, right 1, and then down 3 from there, down 5 from there, down 7 from there, so that'll take me all the way down to the bottom there. -x squared, 7. Solid or dashed line for this one, solid line. So I can try to connect these like so. Again, doing my best on the digital here, that's okay. And here's a great example. If I plug in 0, 0, I get 0 is greater than or equal to 6, which is not true. 0 is less than 6, so I will not be shading inside. So I will be shading outside the parabola. To do that, I like to just draw some arrows like so to show that I am outside of the parabola. And now for this line here, -1 plus x minus y is less than 0. Well, this is gross, but if we turn this into an equation, I can just add y. So I'd have x minus 1 equals y, which is the same as y equals x minus 1, which becomes much easier to graph. So -1 is my y-intercept, a slope of 1, and I'm going to dash this, so I'm just going to go ahead and dash these as I go up 1 over 1. Up 1 over 1, da-ba-da-da, up 1 over 1. From -1, this is going great. Dash, dash, dash. Excellent. Okay, so I'm outside the parabola, but for this one, if I plug in 0, I get, let's see, -1 plus 0 minus 0 is -1 less than 0. Yes, it is. So on this one, I will be shading towards 0, 0. So that means I'm going up and to the right of this dash line. So my shaded area for this one will be outside of the parabola and above the dash line. There we go. Beautiful. All right, last one, letter P. Go ahead and give it a shot. Try it on your own. Let's see how we do. It combines everything we've done so far today. Go ahead and try letter P on your own. Pause the video. Let's see how we do. All right, let's give it a shot. So looking at -3 is less than x is less than 4. I got dashed vertical lines at -3 and 4. So -3 dash vertical line. There we go. 4 dash vertical line. And I know that my function is going, or my shaded area, excuse me, is going to be in between these lines. Y is greater than or equal to x squared minus 8. X squared minus 8 would be right here. 1 and 1, 3 and 3, 5 from there, 5 and 5, and 7 from there. Solid or dash line, this is going to be solid. So what will I do? That's pretty good. Oh, it was really good till the end there. That's okay. Alright, and greater than or equal to, so 0 is greater than or equal to -8, which is true, so that means I'm going to be inside the parabola. So I need to be inside the parabola and inside the dashed lines, and then y is less than or equal to 1/2 x plus 1. So less than or equal to 1/2 x plus 1. There we go. Solid or dashed line for that one? Definitely solid. Excellent. Excellent, excellent. And then from here, let's see, it's going to be greater. So is 0 less than or equal to 1? It is, so I'll be shading toward 0, 0, which means I'm shading below this line. All right, so I need to be inside the dash, under the line here with the slope of 1/2. Let's get rid of this for the last time. As I was saying, we're going to be inside the dashed vertical lines. We're going to be below the line with the slope of 1/2 and inside the parabola for our shading, which means we are shading to there and there, and then we're done. All right. That's it for today's lesson. That's it for all of our notes for college algebra. Congratulations, you have finished the notes. All right, so please look at the practice problems for 5-7. Make sure we're feeling confident with this. The Unit 5 exam becomes available next week, I believe on the 27th. If I recall, I will send an email reminder, of course, when that pops out. I'll also do a Unit 5 practice test, so be sure to look for that. All right, well, this is Mr. Carter signing off from Notes, I believe, for the last time this year. Let me know if y'all have any questions. Feel free to send an email. I'm only an email away. I'll see you next time.